Active shock cancelling neonatal transfer system. The World Health Organization estimates that approximately 15 million babies are born prematurely worldwide every year. In our country, a majority of babies are born in places where appropriate resources is not available and therefore would need to be transferred into an appropriate setting for extensive care. Neonatal transport in India is still in its infancy, with the absence of any dedicated transport system for the referred newborns. A major chunk of critical newborns unfortunately succumb to death soon after reaching the tertiary centers. As a result, close to 40% of neonatal deaths occur within the first 24 hours of admission. The infant is usually subjected to environmental exposures like vibration, translational inertial forces, and rotational inertial moments, often transmitted from the floor of the ambulance during the inter-hospital transfer. These mechanical shocks and vibrations during the neonatal transport can induce irreversible injuries for the newborn baby whose physiological structure is not yet fully developed. Currently used transport incubators lack the feature of active shock absorption. At present, passive suspension systems like shock absorbers, hydraulic dampers, or air-filled mattresses and protective foams are used in order to reduce the impact of the shocks. In this project, we intend to develop an active shock cancelling neonatal transfer system. A steward platform-based motion compensating system is designed, which works on the principle of inverse kinematics. A steward platform is a type of parallel manipulator that has six prismatic actuators, commonly hydraulic jacks or electric linear actuators. In the inverse kinematics of parallel manipulators, the input information is the position and orientation of the end effector, and the length or position of the actuators are calculated as the output. These analyses were done using the MATLAB platform. The design was plotted in the MATLAB, and the road roughness profile data was given as input to one of the platform, and the result was studied. The six links between the two platforms correspond to the linear actuators. Hence, the movement of the linear actuators were plotted as a graph and the corresponding characteristics were studied. Hence, the system was analyzed and the final design of the prototype was developed using the SolidWorks platform. In this video, all the possible movements of the system is demonstrated. The top platform of the system where the incubator with the neonate is placed is always maintained stable irrespective of the movements of the vehicles, thus isolating the mechanical shocks transmitted by the ambulance floor to the incubator. The key benefit of the solution is to enable the safe and comfortable transportation of neonate. It protects the neonate from any potential hazards caused by the environmental exposures, including the vibration, translational inertial forces, and rotational inertial moments, etc. It also helps reduce the neonatal mortality rate and hence helps the country to achieve its Millennium Development Goal of NMR. The aim of our project is to ensure the neonates' safety throughout the transportation. Thank you.